Okay, here's some homework help for the polynomial function section. First question asks for what is the leading term? Leading term is the one with the highest exponent, so that'd be this one. So the leading term would be negative 1/2 x to the 4th. Leading coefficient of the polynomial, so that's a number in front of the x, so that would be negative 1/2. The degree of the polynomial is the highest exponent, be 4. And the polynomial is, since it's a 4, it's a quartic. Linear would just be 1x, cubic would be an x cubed, quadratic would be an x squared, constant would be either x to the 0 or they wouldn't have an x in it at all. It'd just be like the number 8. So it's not those, it's a quartic. Oh, next question. Oh, this one's unorganized. Let's fix that. Plus 8x cubed minus 6x squared. Leading term, x to the 4th. Leading coefficient, number up front, 1. Degree, it's a quartic again. Quartic. I like these questions. End behavior of the graph. Okay, so it's an x to the 6th. Notice they put a negative pi out front just to sort of mess you up. But you're just looking at that x to the 6th. And that's the highest degree. So if it's a negative, even, then the graph goes like this, does something, and then it goes back down. So it has to be this one. This would be high to low. That would be a negative x to the 3rd or any odd number. This one would be low to high. So this would be like an x cubed or x to the 5th. This one would be, it's positive, so it's high to high. That would be like x squared or x to the 4th. It'd be something like those. Okay, usually turn tip to match the function, negative x to the 6th. So it's x to the 6th, so it's same on the start and the end, and negative, so it's upside down. So it's got to look like that. Not that one, not that one, not that one. Got to be that one. Oh, that one. A. Use substitution to determine whether 3 is a 0. Perfect. So I want to know what f of 3 is. So 3 to the 4th minus 6 times 3 cubed plus 6 times 3 squared minus 8 times 3 minus 51. I don't know, maybe. This would be 84. 27 times 6. Maybe do this on your calculator. I don't have a good track record of doing these in my head. 42, 4, 12, 142. Minus 142. 9, that'd be plus 54. Minus 24, minus 51. I don't think you're getting 0 out of that. But do that on your calculator. I have to do it though. 62, negative 62, plus 54, minus 24, minus 51. So this would be negative 8, minus 24 would be negative 32, minus, yeah, you're not getting a 0 out of that. No. Find the zeros of this polynomial. Ooh, and there's a 4 there too. Nice. So let's write that out. So it's x squared minus 25, and there's 4 of them. Okay, each one of them can be factored to x minus 5, x plus 5, x minus 5, x plus 5, x minus 5, x plus 5, x minus 5, x plus 5. Okay, so I've got x minus 5. How many of those do I have? 3, 4. And x plus 5, I've got 4 of those as well. So if I look at zeros, the zeros from this would be 5. Since there's 4 of them, it'd be multiplicity of 4. This one would be, the 0 would be negative 5, and again, multiplicity of 4. Do they have that? Plus or minus, no. Plus or minus, oh yeah, that's the one. Not those ones, this one. 7, find the zeros of this polynomial state multiplicities. Okay, so I think that's sort of the form, the normal quadratic form. I'm going to put an x squared out front, x squared. Things that multiply to 80 and add to 21. 16 and 5. I'm saying 16 and 5. Oh, not minus. Minus 16 and a minus 5. Is that right? 16 times 5 is 80. 5 and 16 is 21. Yeah, that's right. Okay, so let's set this equal to 0. So either x squared minus 5 is 0, or x squared minus 16 is 0. This one I'll have x squared is equal to 5. Square root principle on both sides, I get a plus or minus root 5. This one, x squared is equal to 16. Square root principle, I get x equals plus or minus 4. So they say zeros are type exact answers using radicals if you need it. And look, there's no doubles, so each multiplicity has, or each zero has a multiplicity 1. So I would type in, you could probably just type in plus minus root 5, comma, plus minus 4. Okay, to determine whether the statement is true or false, x minus 5 to the 10th, oh, multiplicity of 10, nice. X plus 6 to the 7th. Then the graph of the polynomial function crosses the x-axis at 5. So this would be a 0 right there. And so you'd have 10 x minus 5, right? And so the 0 would be x is equal to 5. So 5 is a 0, but if the multiplicity is even, it does a bounce at that point. So at a positive 5 right there, the graph, I'm not sure if it'll come from the top or the bottom, but it'd come and bounce and go back. And so it would not cross, no. The graph of the polynomial crosses the x-axis, no, false. So there's no truth to that statement. So it's got to be this one, either B or D. Statement is false because that is a factor of the given polynomial and the exponent 10 is odd. Well, 10 is not odd. Can't be that one. 10 is even. Thus, the graph bounces. I guess I should use the proper term in math. It'd be tangent to, so it would come down and bounce. Okay, next question. The number of U.S. travelers is modeled by this, where x equals 1990 and 1 is 1991, etc. So they say approximate the number of U.S. travelers to other countries in each year. So in 1990, how many? So in order to do that, I'm going to figure out what the P is. In 1990, that's 0. So I'm going to put a 0 in everywhere there's an X. Now I would advise you to do this on the calculator. Putting brackets in everywhere they're supposed to be. This is one where if you try and work it out each term individually, it gets so that it's fairly unwieldy and it's easy to make mistakes. But most of your calculators, including decimals, you can just type that whole thing in and your answer comes out to some number. And then they want you to do that for 2000, so that'd be 10 years. So you'd be figuring out P of 10. And they want 2009, that'd be 19 years. So P of 19. So they need to plug 10 or 19 everywhere there's an X. Okay, last question. Determine the degree and the leading term of the following polynomial function. The leading term of the polynomial function. Oh, that's tough because this one's all multiplied out already. And then they want to know their degree. Okay, let's write this out and see if we can just sort of deduce it. X to the 6 minus 1, x to the 6 minus 1. There's 2 of those. And then there's 3 of these. Plus 2, x squared plus 2. So to figure out the whole polynomial, you would have to FOIL all this stuff. FOIL, FOIL. And then once you have that, FOIL it with this. And then FOIL. You get the idea? This would be painful. However, if you take the leading coefficient for each binomial, those ones, if you multiply those together, that'll tell you what the highest degree is. And there's no numbers in front, so it's got to be 1x, you don't need the 1, to the some exponent. And that exponent, if you multiply in common bases, you just add their exponents. So this would be a 6 times a 6. So those together would be a 12. If you times that with this one, you tack on another 2. Tack on another 2, tack on another 2. So it'd be 12, 14, 16, 18. So the degree of the polynomial would be 18, and it'd be 1x to the, or the leading term would just be x to the 18th. All right, hopefully that'll help you out with that homework assignment.